Hello, Science 10, and welcome to our video on significant digits and scientific notation. We're starting on lesson 1 today. So our goals for today are understanding what are significant digits in science, what are the rules that we have when we apply significant digits to things like calculations, how do we use something called scientific notation, how do we put a number into scientific notation, and how do we take a number out of scientific notation. So we're going to start with significant digits. So why do we use significant digits? What's the importance of them? So in science, when a number is given to you or stated, it indicates the value of that number, but it also is conveying to you the accuracy of the number, hence why we use decimal places. If you think about weighing something on a scale, it's usually to the hundredth or thousandth of a gram, so 0.00 sort of thing. Okay, so it might be 100.01, for example. That is the accuracy of the number. What we are essentially trying to do when we use significant digits is answer the question of do the digits give me the most information about my data? So when I look at my number, what am I actually getting out of that number? How precise is that number? And how do I use it when I'm using an equation? So let's talk about an example here. So let's say we're measuring materials in a lab on a scale, and our scale says 2.003 grams. You would normally go over to your lab book and you would write down that number, okay? You would write down 2.003. You would not just write 2 down because 2 isn't 100% precise or accurate. The scale read 2.003. Okay, so that's why we use significant digit, is because we want to know how accurate our number is. So when we look at this, which one of these gives us more information about the item? 108.653 or 109? If you think about it as weights or as the amount of something, okay, 108.653 is pretty accurate. 109 is rounded up, okay? So it's a little less accurate. So we have a couple rules for when we're trying to figure out significant digits for how do we use it when it comes to telling numbers in any sort of scientific form. So what you're going to always do is you're always going to count from left to right, starting at the first non-zero digit. That doesn't make 100% sense yet, but we're going to work our way through. So we're going to write down a couple of key things. So rule number 1 in your book says zeros at the beginning. Okay, so you're going to fill this in. Zeros at the beginning. If there are zeros at the beginning of the number, they are not significant, okay? So it's key to write that down. So my example, also write this down, is 0.000021, all right? So looking at this example, all of these zeros aren't significant. So if I asked you to tell me the amount of significant digits in this number, you would say 2, because the 2 and the 1 are the non-zero digits. So up here it says you count from left to right, starting at the first non-zero. So I'm looking for a non-zero. Here it is, 1, 2. I counted from left to right. So the first rule is if there's a bunch of zeros in front, they don't count. Find your first non-zero digit and count it. So this one has 2. The next rule we're going to talk about is what happens if there are zeros in the number. So zeros within a number are always significant. So up here it says you always want to start counting from the first non-zero digit, left to right. So in these examples here, there's a 0 here and 2 zeros here. Up here I said don't count the zeros, but that was because they were in front. Down here, you need to count the zeros because we always start from left to right with the first non-zero digit. So looking at this right away, here's a non-zero. So I have 1, 2, 3, 4 significant digits in this number. If I'm looking at this one, it's 1, 2, 3, 4 as well. Even though there's zeros in between, because it started with a nothing, it started with a number that wasn't zero, we count all of them. So zeros found within a number are always going to be significant when counting significant digits. Now there's 2 parts to this third rule. This is called trailing zeros. Trailing zeros are like zeros at the end of a number. So if you have a number that has a decimal in it, we're going to call these zeros significant. And I'll show you what that means here in a second. If there is no decimals, then we're going to say they're not significant. So that means trailing zeros have two rules to look at. So what does that mean in what I'm saying? So my examples are right here. This is 4.00. 4, I'm going to start counting left to right. There's 1, 2, 3 significant digits here. Okay. And that's because there's a decimal. So since there's a decimal, I have to say these are significant. Why? Because this is showing me the accuracy of the number. I'm saying I weighed something to be exactly 4.00 grams or 4.00 liters or 4.00 milliliters. Okay. I'm being precise by adding my decimal. This number here, 37,000, there is no decimal. So this could be simply a rounded up number. It could be an estimation number. There's no real accuracy in this number. It's just a statement of 37,000. So because there are no decimals located in this is a comma, we don't actually count these trailing zeros. Instead, we say there are two significant digits, the 3 and the 7, because again, we count left to right. But in the case of the trailing zero, because there's no decimal here, we're not going to include those zeros. So significant digits here are 3, here it's 2. Even though this number is bigger, there's no decimal place to tell me that those zeros are important. So please make sure you have all 3 of these rules written down, and then we're going to go through some examples, and you're going to write down how many significant digits are found in each. So counting sig digs, let's give it a try. Here we go, examples. So here's all of our examples. And what we're going to do is we're going to start at the first one, and we're going to count how many significant digits using our rules. So rule number 1 is if there's any zeros in front, don't count it. There's no zeros in front, so I'm going to start counting my significant digits. 1, 2, 3, 4, 5. There's no trailing zeros. There's no zeros in between. So I can say that this number has 5 significant digits in it. All right. So again, looking at number 2, there's no zeros out front. There's a 0 in the middle, but I'm going to count it, and I'm going to count all of these digits. 1, 2, 3, 4, 5, 6. So there are 6 significant digits in this number. All right, let's look at this one right here. Rule number 1 is if there's zeros out front, do not count them. Go find the first non-zero number. So I'm going to go all the way down here. There's only one number. So this has 1 significant digit because none of these zeros count. All right, they're all in the front. This one right here has a 1, then a decimal, then a bunch of zeros. So my rule number 3 says that if there's trailing zeros but a decimal, I need to count it. So that means I have more than 1 significant digit. This should say 5, not 4. This should say 5 because there's 4 zeros here. This is 5. Not sure why I have. Oh, in your notes, ladies and gentlemen, it is 4. In my presentation, I have the wrong number. So put 4 in your notes because there's 1 with 3 zeros, so there is 4. All right, the last example there is just 70,000. There is no decimal place, no nothing. So because there's no decimal place, all of those trailing zeros are not going to be counted. So we're going to have a significant digit of 1. All right, so please make sure you have those in your notes. That's how we use significant digits just to count, but we will never just use significant digits like this. We're always going to use significant digits in calculations because that's where we're headed. We're talking about physics, we're talking about chemistry, we're going to use sig digs in the sense that we're going to use them in calculations. So there's rules that you have to use when you're doing addition and subtraction. So the rules you need to remember are, remember if there's anything out front that are zeros, don't count them. If the zeros are in between, count them. If there's no decimal place, don't count trailing zeros. Those are things to remember. But now we're going to add some more rules. In addition and subtraction, the answer has to contain the same number of decimal places as the least accurate measurement. You're probably thinking, huh? What does that mean? So we're going to go through an example. I have the example if you add 0.507 grams of salt to 150.0 grams of water, what is the mass of the solution? So I'm adding these two numbers together. what I need to do first is I need to figure out my significant digits. My answer needs to be put to the right significant digits. So this says has to contain the same number of decimal places as the least accurate measurement. Least accurate means the least amount of decimal places. So if we look at this one here, there's how many decimal places? 1, 2, 3, because here's the decimal, there's 3 places after. Here's the decimal, how many are after? Just 1. So when it comes to doing significant digits for addition and subtraction, our answer is only going to have 1 decimal place after the number. So again, figure out your significant digits. There's 1, 2, 3 in this one, because remember, we're going to count this 0, but we're not counting this 0. 150, because there is a decimal and these 2 zeros are trailing. There's a decimal, I count them, but I'm only counting the 1 at the end. So 150 has 1 significant digit because I'm only looking for after the decimal. Then what I'm going to do is I'm only going to use the number of decimal places, okay, that my smallest one has. So I said 0.0 is 1, so I'm going to use that. So I'm going to add these all together. 0.507 plus 150.0 gives me 150.507. But because I'm only allowed to use my least accurate measurement, I have to check my rounding, and I'm going to make it 150.5 grams because 150.0 is the lowest number after the decimal. Okay, so that's how you would do this question in addition and subtraction. Addition and subtraction is always look at your decimal, how many decimal places are there after, take the smallest one. Multiplication and division are a bit different. Multiplication and division, okay, you have to actually use all of the digits, but you're going to look at the one that has the least amount of significant digits. So now we're not working with decimal places, we're just looking at the entire all the numbers that we have. So let's look at our example. If 2.50 moles of water, okay, is multiplied to its molar mass of 18.02 grams per mole, what is the mass of water? So we're going to multiply those two together. So step 1 is figuring out your significant digits. Now this one says we just count all the digits, which ones has the lowest amount. So if we look at this, 2.50 moles has 3 significant digits because we have 2, 5, and a 0. That 0 counts because there's a decimal. 18.02 has 4 significant digits. So our answer has to contain 3 significant digits because multiplication and division says you have to use the one that has the least number of significant digits. So our lowest number of sig digs is 3. So when we multiply this together, 2.50 moles multiplied by 18.02, that's what I'm showing you there. They're side by side, so that means I'm multiplying. Ends up giving me 45.05 grams. But the problem is I'm only allowed 3 significant digits overall because that's how many I had in 2.50. So I'm going to look at my answer, 45.05, and I'm going to round up my 0.0 to a 0.1 and then say this is 45.1 grams. So again, in addition and subtraction, you're looking at the numbers after the decimal place. Multiplication and division, you're taking all of them into account. The last couple things I want to talk about is rounding and the rule, and there's one exception to the rule. So when we did the last couple examples, I was saying double check to see if you are rounding properly. I just wanted to give you guys a quick reminder of what rounding rules are. So if you have a number lower than 5, so let's go back. For example, in this one right here, my first example where my number ended up being 150.507. What you want to do is you want to look behind the 5, the 0.5. There's a 0 and a 7. Okay, I want to know if I need to round that 0.5 up or leave it as is. So I'm going to go and notice that behind the 5 is a 0. So because it's lower than a 5, I leave it and I don't change it. Okay, example would be 4.0131 to 2 decimal places. Okay, I would say, okay, this answer is 4.01 because my 3 isn't big enough to round that 1 to a 2. Okay, so 3 is not bigger than 5. So remember, rounding, anything lower than 5, leave it as is. If a number is 5 or greater, okay, so it's bigger than 5, you need to round to the next digit. So for example, if I have 0.43521, okay, and I want to round this to 2 decimal places, I would have to write it as 0.44 because that number 5 is 5 or greater. So I'm going to round up to the next whole number, which is 0.44. All right. Those are just quick reminders of how to round because you're going to need to do that with significant digits. So the final thing about SIGDIGs is that there's always exceptions to rules. We know this. There's one really important exception to significant digits. If I give you a number that is exact, you don't have to follow the rules of significant digits. For example, if I said the word dozen or a couple means 2, dozen means 12. If I say, what's another one? I can't think off the top of my head of another one, but essentially, if I give you an exact number, so what is the mass of a dozen baseballs? A dozen means 12. I do not need you to count that 12 as part of your significant digits. You would just use the mass number. Because 12 is an exact number, it does not apply to the significant digits rule. When we get into more examples, you'll see this and I'll remind you guys of this, but I just wanted you guys to have it in your notes just in case we come across it in the next little bit. So that's it for significant digits, ladies and gentlemen. You have a practice page on page 4, okay, before you start your scientific notation video. Please do your practice and then check it over and let me know how you do. And I will talk to you soon.